This is Srikanth, Assistant Professor of Computer Science, Engineering and Data Science. In this session, I am discussing about the subject is optimization techniques. In this, I am going to discuss what is the meaning and significance of optimization. What is optimization and what are the significances of optimization. In this particular module, we are going to study about the outcome. What we are going to get is understand the concept of optimization, formulation, and solve the linear programming problems. In this session, these are the things which I am going to continue. That is the meaning of optimization, nature of optimization, scope of optimization, and significance of optimization. The name itself says optimization. It is nothing but which is going to produce, which is going to give us an efficient system. Either it may be maximizing the profit or minimizing the losses. Anything which is corresponding to maximize or minimize, which will be done with this optimization. Okay. So the exact definition for optimization is optimization refers to the process of making a system design or decision as effective, functional, or efficient as possible. So it involves the best alternative from a set of feasible solutions, often subject to certain constraints. Whenever we go this optimization with the mathematical perspective, that is, whenever we are going to deal with optimization is nothing but either we need to maximize or minimize. Whenever we are going to deal with maximize or minimize, we need to carry on with mathematical processes. So with this, the mathematical discipline which is concerned, which is to find the maxima or minima of a function which is under the specific constraints. Okay. So we are going to find the maxima or minima of any particular function or any particular real life example with certain constraints. The simple examples are of minimizing the cost of production. If let us consider a manufacturing industry is available. So here we are going to produce some components such that which is going to maintain the cost. That is, we need to maintain the cost of the production within a particular limit. We need to we need to produce the components with a certain limit of cost. And the next one is maximizing profit or efficiency. That is, we are going to increase the profit. Whenever we are having less cost, we can get the maximum profit. And also, we need to, not only with the less cost, we need to maintain the components should have a good efficiency. Then only the market is going, in market, the component is going to be in a particular position, that is which everyone can purchase that particular product. So we need to be very careful, like minimizing the cost. Whenever we are minimizing the cost, we need to be very careful about the constraint. That is, we need not to compromise on the quality of the products. So we need to minimize the cost along with by maintaining the quality of the product. So that is our main constraint, main condition. That is, we need not to compromise on the quality. That is, and the next one is maximizing the profit. This is also, we need to be very careful about how the other companies of the same product is producing and what are the differences. Based on that, how much profit we are going to be maintained. That is also should be in an optimized way, and we need to increase the efficiency of our production. And the next one is reducing energy consumption in an electrical circuit. If let us consider any electrical circuit or if let us consider our house which is having a certain number of electrical components, so we need to reduce our the per month units, then only our cost of per month electricity will be reduces. So that is when the electricity appliances are not in use, we have to reduce, we have to shut down those electrical appliances so that we can reduce our energy consumption, so that which will be used in a optimized way. That is, if we are going to use the automated components, so that when a sensor which is used in a light, when we use a light sensor, the light sensor is going to sense the light and immediately it is going to reduce the immediately it is going to reduce the illumination when no one is available, or switch off the light when no one is available. And evolutions of operation research, here the early beginnings are, its roots are in the first half of the 20th century are started. The Frederick Taylor, whose work delayed the application of scientific principles in management. And in the World War II, operation research found its way mainly during the Second World War, because during the Second World War, in order to optimize the whatever the appliances they are using or whatever the guns they are using, we have to use in an optimized way, because it is, we don't know when it is going to stop. So we have to continue use the continuous production for all the bullets, everything. So that's why the operation research found its way mainly in the Second World War. The post-war development, after completing the Second World War, the many techniques which are used in the Second World War that are applied to the industrial planning, and hence the formation of operation research societies and journals. And technological advancements after 1950s and 1960s, the use of operation research became more efficient, and it was now possible to solve some of the problems through simulation and optimizations. That is, we can use these optimization techniques in the simulations so that we can get a particular output within a optimized way. In the modern day, the upcoming and current advancement of big data and analytics in operations research further increases its range of uses and fields of practice. And the next one is approaches to operations research. Here, the operation research can be done in more ways based on the type of problem and the available data. That is, which type of problem which is used for that particular optimization, or which function which is using, based on that, and also the available, based on the available data. We are having several types of operation research approaches. The first one is descriptive operations research. This can be explained as a process of defining and creating an understanding of the context of the system at the current time. That is, whatever the data which is available, or whatever the problem which is available, that is corresponding to the current time. That is, frequently gathering data or studying it, trying to find a pattern or trend. That is, if we are having a particular problem, so frequently we need to gather the data corresponding to that particular current system, and that we need to study properly, and we have to find what is the pattern which is following that particular problem, and we have to find the solution within an optimized way. And also statistical analysis and data mining. This is also can be used in the whatever the data which can be used in the descriptive operations research. And the next one is predictive operations research. Predictive is nothing but we are going to predict the value in the future. That is, what will happen tomorrow, or what will happen after 1 week, or what will happen after for 1 month. That futuristic operations research is nothing but the predictive operations research. It is the process of analysis of past events as a way of predicting events in the future. The following models are helpful in outcome prediction. That is, the first one is regression analysis. That is, we are going to take the previous data and we are going to predict what is going to happen after that. And the next one is forecasting. That is, we need to forecast the by using the previous data, we need to forecast what will be the demand. Like if let us consider electrical demand for a particular place. So we need to consider all the parameters corresponding to the electrical systems, and based on that we have to forecast. That is nothing but estimating the next data corresponding to next month or next year or next 5 years, like that. Whatever the prediction is there, that we can do by using predictive OR. And also we can also have simulation models for forecasting any data. And the next one is prescriptive operations research. This is the most advanced level of problem solving, where one has to find the optimal solution to a certain problem. That is, we need to find a particular solution for the given problem. That is, when it is asked to calculate what is the maximum value, or what is the maximum value, or what is the minimum value for a particular function, we need to use this predictive operations research. Here are some of the examples where we can use this prescriptive operations research is linear programming techniques, integer programming techniques, and network models. And hybrid approaches are whenever we are going to combine all these descriptive, predictive, and prescriptive approaches, which can be integrated to tackle complicated issues more effectively. That is, whenever we are going to get the complicated issue, then we can use all these approaches and we can create a hybrid approach in order to solve the complicated issues. And the nature of optimization, the key characteristics are: aspect is whenever we are having an aspect of decision oriented. That is, whenever we are having a particular condition such that decision oriented, it has to happen in that particular case only. In that case, we have to use the description based on the selecting the best decision among all the alternatives. We need to use the selecting, choose the best decision for solving that particular problem. And the next one is goal. That is, we have to, whenever we are having maximizing the cost, okay, that is only our main goal. So clearly we have to define our objective function. And constraint based, that is, which is bound by one or more constraint. That is, we are going to have some constraints for any particular objective function, that is constraint based. And quantitative, which is going to deals with the mathematical models and numerical data. And iterative is nothing but it involves continuous improvement until optimality is reached. And types of optimization are, we are having different classifications of optimization. That is, linear versus non-linear, constrained versus unconstrained, and deterministic versus stochastic, and single objective versus multi-objective. The linear optimization, here both objective function and all the constraints are linear functions of decision variables. Here the linear function is nothing but which is not having any non-linearity elements. So both the objective function and all the constraints also linear functions. Then only we can call it as a linear function. If let us consider the maximized profit, z is equals to 3x plus 4y. Here x is linear, and y is also linear. And the method used is simplex method or graphical method, where we are going to use this linear optimization. And nonlinear optimization, either the objective or at least one constraint is nonlinear. That is, if we are having nonlinear objective function also, we can call it as nonlinear optimization, or at least one constraint is also nonlinear, then we can call it as nonlinear optimization. That is, if let us take the example, minimize the cost where z is equals to x square plus y square, that is subject to nonlinear constraints. The method used is gradient descent or Newton's method. And whenever we go with unconstrained optimization, that means there are no restrictions on the decision variables. There are no restrictions on the decision variables, no constraints, no conditions. Then we can call it as unconstrained optimization. No restrictions are nothing but whatever the optimal function we are going to solve without any conditions. That is, if we are having only function f of x which is equals to x square plus 4x plus 4, if there is no condition, then that is called unconstrained optimization. Okay, so the method used is derivative based methods. And constrained optimization is whenever we are having one or more constraints, equalities or inequalities, that is, whatever the constraint which we are going to have, that is, whenever we are having less than or greater than or equal also, we can call that particular optimization as constraint optimization. Here we are going to maximize, the example is maximize f of xy, which is subject to x plus y is less than or equals to 10, x comma y is greater than or equals to 0. The method used is Lagrange multipliers and barrier interior point methods. And deterministic optimization, here all parameters are known and constant. All parameters are known and constant. No randomness is involved. No randomness is involved. Then we can call it as deterministic optimization. The route planning with known travel times. That is, whenever we are going for any particular trip, when we know that particular route or whatever the travel times, we can easily reach in which way we can move from our starting place to that particular trip. And method used is linear or non-linear programming. And stochastic optimization, here some parameters involve uncertainty or randomness. That is, whenever we are going to consider weather forecasting or weather prediction, then we can use the uncertainty and randomness, weather or demand. Because whenever we go with electricity demand, sometimes we may have high electricity demand, sometimes we may not have. Like that, weather also, it is going to change every time to time. So these are the parameters which will comes under stochastic optimization, where example are portfolio optimization with uncertain returns. The method used is genetic algorithms, simulated annealing, and Monte Carlo methods. And single objective optimization, which is going to focuses on optimizing one goal, that is either maximize or minimize one objective function, that is, which is going to minimize the cost of transportation, which is wherever we are going to use, either based on our requirements, either we have to use the maximize the profit or minimize the cost. So based on that, we may have maxima or minima calculations. So here, minimize cost of transportation. The method used is linear programming, non-linear programming, and gradient methods. And multi-objective optimization. We may have multiple objective functions, that is, which involves optimizing two or more conflicting objectives simultaneously. Whenever we are having two or more objectives, that is, we need to minimize the cost and maximize the quality in manufacturing. Then we have to call that particular optimization as multi-objective optimization. The method used is Pareto optimization, NSGA tool, and weighted sum method. And scope of optimization here, the optimization is having scope in different areas. If let us consider in engineering, structural design, thermal systems and process optimization, where we can use this optimization techniques, and operations research, wherever we can use this in inventory management, transportation, scheduling, and economics and finance, that is portfolio optimization and cost benefit analysis, and machine learning, that is loss function minimization, parameter tuning. Whereas in computer, we can go with the compiler optimization or algorithm tuning, and energy systems, where we are going to use the load dispatch and renewable energy integration. And significance of optimization, as we have discussed, the last one is the significance of optimization. Why is optimization important? That is, optimization is important because we need to get some benefits, and with that benefits, what we are going to achieve, that is the cost efficiency. That is, whenever we have reduced the cost, automatically it is going to reduce the usage of wastage and improves the profits. When the cost is reduced, means profits will increase. And the next one is productivity. When we enhance the operational performance, automatically the production will increase and also output will increase. And the next one is decision support. That is, whenever we are having some particular constraints and we are solving those constraints, which is going to provide a rational basis for complex decisions. And competitiveness, which is going to offer strategic advantage in industries and also markets. And sustainability, which is going to promote optimal use of limited environmental resources. And automation, where we can use the programmable logic controllers and robotics in order to learn the efficient strategies, like in order to optimize the cost of electricity, we have to use the automated systems. So whenever we use automated system, automatically whenever we use the sensors, automatically fans, ACs or lights, when no one is there, automatically they are going to get switch off. So we have to use the optimized operations. Along with that, we have to check what is the cost. That is, optimize means whenever we are reducing the cost of electricity, but the investment of that investment cost is more, that is not the optimized way. We have to compare whatever we are reducing and what we are investing on that particular system, so that if it is comparable, that is, if whatever the investment which we have given within 1 to 2 years, if that particular savings are done, then we can go with that particular operation. Otherwise, we cannot go, because we need to compare both the whatever the investment which we are placing and whatever the saving which we are done. So based on that, we have to proceed for the optimization. Today I have given the basic introduction and significance of optimization. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.